right. Well, thank you very much. I'm Nancy Bull-Borman. I'm a researcher at the University of Minnesota, and I will be discussing manure nutrient trends from 2012 to 2022. Maybe you've seen me at the last Waste to Worth. I was working on my PhD, so this is some things that we found out after that. So, all right, we're at the very last session of the conference here. I mean, many of you have seen these or know these things that, manure is very variable in its nutrient concentrations. We do have some published US manure characteristics, but many of those publications are over 20 years old with data even older than that. And we know there's thousands of samples that are analyzed annually in the United States. So just going through this particular study that we're working on, we're using recently aggregated manure data through ManureDB, which is a manure nutrient database developed at the University of Minnesota. For this particular section, we took the data from 2012 to 2022 for 8 common livestock and poultry categories, and then compared those, looked for nutrient trends across 11 years, and then also looked at some regional comparisons as well. Just to go a little bit background, how many of you have heard of ManureDB before? You raise your hand. Okay, great. Okay, got some new people. So yeah, 3 years ago at Waste to Worth in Toledo, we were just talking like about the very start, and like we're trying to figure out how to create this database. So these are some of the milestones since that time. In November 2022, we got our first data sets were uploaded, because you can imagine we had to do a lot of like figure out a standardized template, working with all these different laboratories and units and methods and wet or dry basis, trying to make sure we're getting that all set where we can actually compare some of these things. May 2023, we had the website went public. And then last January 2024, we had data downloads available. And then last summer, we had our first data archived at USDA's National Agricultural Library Ag Data Commons. And we do plan to archive a snapshot of our database annually at Ag Data Commons going forward. There's a QR code for the website, or there's the Z link, or really just search ManureDB and it should pop up. All right, so for this particular study, we wanted to see if there were some regional differences, for the regions that had sufficient samples anyways, and then also check were there some trends across this 11 years, 2012 to 2022. We looked at total nitrogen, ammonium, nitrogen, phosphorus, and potassium, and for eight common poultry and livestock manure types. So for this slice of data used in this study, it was over 300,000 samples. Just today, we're close to 500,000 samples in the database for reference. We had liquid and solid beef manure, liquid and solid dairy manure. We had solid chicken broiler, solid chicken layer, solid turkey, and then also liquid swine manure were the categories we kind of narrowed it down to. And that's just a screenshot of what the website looks like today. As far as regions, when we're trying to look at how are we going to like divide up the regions, we kind of looked around to what other people had done. We chose the USDA Climate Hub region areas and separated them out pretty well according to that map. So that's how we did our regions. And you'll see later, but the majority of our samples so far, and the ones that we used for some of our comparisons, were in the Midwest, Northeast, and Southeast US. Just a quick thing about methods. When you're dealing with this kind of data, we're looking at medians, and it's a lot of non-parametric things. So to compare regions, we use the Mann-Whitney U test. And yeah, we compared for things in the same year for those regions that had at least 500 samples for that animal type in that time frame, and then for those 4 analytes. And then for the method to check over time, we used the Mann-Kendall trend test, again, for regions that had sufficient number of samples to look at. This showed you, is there no significant trend? Is there a significant increasing trend or a significant decreasing trend for a particular nutrient? Okay, so what have we learned so far looking at those items? Okay, for regional solid comparisons, I just did a little slice on the side here just so you can kind of see what I was looking at. So we had for dairy solid manure for total nitrogen, we had enough samples in the Midwest, the Northeast, and Southeast. So we had each one of those comparisons. NS means not significant. So for total nitrogen, and I just picked this first year here, 2012, they were significantly different between the Midwest and Northeast for the total and median for dairy solid manure. So like in this particular year, only the phosphorus for Midwest and Northeast were not significant, and Northeast and Southeast K. So that's what these 396 comparisons. We have all these years for all these analytes and all these regional comparisons. So yeah, 2/3 of the time we had significant differences between regions. Of the solid manures, the greatest differences were the dairy solid manures. 79% of the time they were different between regions. Least difference was turkey solid at 52%. So at least half the time they were significantly different. Okay, now looking at the regional liquid comparisons, out of all those comparisons, 91% of them were significantly different. Just a little note, analyte concentrations for all the liquid swine and dairy samples in the Midwest to Southeast comparison were all significantly different for all those analytes and years. So that's, I mean, and just thinking about it, there's a lot of different storage. We didn't separate out storage. I mean, there's different climates, different storages, different feeding, bedding, those sorts of things, or not bedding for liquid, but, storage is a huge factor. So, I mean, this really shows, how these liquid manures can be, and that regional, looking at regional nutrient concentrations are likely or closer to a nutrient approximation than looking at a whole US average or something. So that really stood out to us. Okay. Now looking at the trends across that decade time period, we didn't, I guess just overall, 25% of the solid samples had a significant trend, either increasing or decreasing, and 18% of the liquid samples. So this wasn't as big of a thing as the regional differences, but I highlighted the ones that did have significant trends one way or another. So yeah, so like for example, the beef, the Southeast region had a decreasing trend in ammonium, and broilers, 2 regions had decreasing ammonium, one Southeast had increasing K. Layers, the Southeast region had 3 analytes decreasing. Dairy, solid, Midwest had decreasing P, Northeast had decreasing nitrogen and ammonium N. For turkey, this was the only one that had contradictory things for analytes. The Midwest had a significant increasing P, and the Southeast had a decreasing trend for P. So that was the only one that was, kind of contradictory of each other. As far as liquid manures, liquid beef didn't have any significant trends. For dairy, only the Northeast region had decreasing for all 4 analytes looked at. And then swine, only the Southeast had an increasing trend for ammonium. So some trends seen, but not, I guess, overwhelming majority. I just pulled like 2 of the graphs that kind of shows this information in a different way that I had in my dissertation. So this is just pulled the dairy liquid manure. So the blue is the Midwest, the Northeast is green, and the Southeast is red. Where the the dots are, that's the median. The top one is the 75th percentile. The bottom is the 25th percentile. So that's the middle 50% of samples. So that also shows too, like half the samples are outside of those ranges as well. So, I mean, that shows how variable it is. The end shows how many samples, like here for the Midwest, we had over 43,000 dairy samples that had a total nitrogen analysis. So anyways, you can kind of see across, but here, this is like, yes, this is very different than the Southeast region, and the Northeast and the Midwest, are closer some years, or at least tracking along the same. So anyways, it's just a kind of another way to see. There's arrows here too that show if there's a significant trend. And again, this was the Northeast region. This is the one that had the decreasing trend for all four analytes, but which you kind of see slightly. But we had graphs for each of those. I didn't put them all in here, but I did put one other one in here. I put in the turkey solid one. This is one that wasn't quite as different between the Midwest and Southeast, but and I put, this is the one that had the opposite, the increasing trend for P for the Midwest and the decreasing trend for P for the Southeast. So don't know if it's samples or is that a feeding trend or what, but anyway, kind of interesting to look at it those ways. Looking at future plans for this project, looking to get some journal articles published. Actually, Friday afternoon, I pressed submit on a Journal of ASABE article about how we design the Manure DB project. So hopefully that will be coming out in the near future. We plan to continue to archive data annually at the Ag Data Commons, like I mentioned. We're continuing incorporating new data too. And from labs we've already worked with, I just put out a call and said, hey, if you're ready to send in your 2024 data, please send me your spreadsheet and we'll get working on that. So I do have some backlog of more data to put into it. So we're hoping to keep this current as we have a couple more years of funding on this project. We're looking to collaborate with ASABE on updating the manure production and characteristics standard. I know that group committee is planning to meet soon. If that's something you want to learn more about, let me or some other folks know, and we'll tell you more about that coming up. I guess how can you get involved? If you have any connections with other data generators or users, we'd definitely like to see that. You can see on the website the statistics of how many samples come from like the different states and such. So some states, we have thousands and thousands of samples, and some we might only have a handful. So especially, we're in the Western US, we definitely would be interested in representing more parts of the country. If you have any data analysis ideas or questions, it can kind of help, query our data or help to answer questions or look at that way. Another thing you have to do on our website, we do have a collaborator tab where you can see some of our data partners that if they wanted their logo on there, we would put it on there. So you can kind of see who all we work with today as well. And also let us know your experience, using the website or the data set. And, do you have any questions or issues? I mean, we're improving it all the time. Like we've added with the data download. Before it was only in percent that you could do. Now we have like pounds per 1,000 gallons, pounds per ton options too. We're adding more like outlier detections and different validation measures. Starting to still catch, sometimes if a unit was mislabeled on the data input, now we're starting to catch things when you do a select for a query for something. So we're continually trying to, improve the data set to what we can. I guess to wrap things up here, Manure DB just offers a robust look with more quantities and representing a larger geography of samples than we've had in the past. And that's what's published. We do know these regional differences are a really big deal and have a, really constitute a difference. We saw it most years for almost all the different animal manure categories, but especially for those liquid manures. Most of the time there were not significant regional analyte trends, but there were a few. Um, and I think at the end of the day, we still really want to highly encourage, manure sampling on individual farms. You can see there's a huge range, but this can offer a benchmarking opportunity. But really knowing what's on your farm is still the best for your nutrient management plan. I'd like to acknowledge our team working on this. Melissa Wilson and Aaron Cordes were the PIs on this project. The rest of our team, the stakeholder committee, definitely our participating labs and collaborators and our funding sources.